Okay, today we're going to be taking some notes using this weird piece of paper that I've already cut out. I have put this on Schoology for you so that you can print your own, or you can copy it. You can just trace the outline, or you can just take these notes. Either way, it's fine. Basically, this is going to fold into a pyramid because today we are talking about pyramids in biology. So I'm going to start on this triangle right here. And the way that this is going to work is it's going to end up folding like this into a pyramid. So the point in the middle is going to be the top. So that's how I've arranged it. All right, we're going to start by making a food chain. So in our food chain, in the safari, we start at the bottom with our grasses. And there are lots of different species of grass. So I'm just going to put grasses in general. And these are our producers. That's the name of the trophic level. Then the next trophic level are the things that eat the grass. And in our example, we're going to use wildebeest. And wildebeest are our primary consumer. So a way to write that is like this symbol here. It means primary. So 1 and then the little degree symbol means primary, and these are consumers. And they're consumers because they get their energy by eating, whereas producers get their energy from the sun. All right, the next level, what is something that eats our wildebeest? Well, we have in the Serengeti, we have our lions. So lions are going to eat the wildebeest, and they are called secondary consumers. So there's our primary, this is our secondary, also consumers. And one of the ways that we can represent this is with what we call a pyramid of numbers. And it's bigger at the bottom, smaller at the top, because there are more grass than there are wildebeest. There's more wildebeest than there are lions. So in a pyramid of numbers, we record how many organisms there actually are. So in this case, in our grasses, there are billions of grass. In our Serengeti ecosystem. If we then look at how many wildebeest there are only 1.5 million. It's actually quite a lot, but compared to how much grass, it's quite a bit smaller. Now, if we look at how many lions there are only about 3,000. So as we get up higher levels, in our trophic levels, we're going to have fewer and fewer organisms. And that's how a pyramid of numbers is arranged. So this is an example of a pyramid of numbers. All right, I'm going to turn this. We're now working on this triangle here. And in this triangle, we are going to talk about biomass. And we're going to define biomass. So biomass is the dry mass of all the organisms in a trophic level. So we can think of this for a food chain. So for example, if we took all of the dry mass of the wildebeest, but we could also look at this as a food web where we would include all of the primary consumers. So that would be things like the wildebeest and zebra and giraffe and elephants. So when we say dry mass, what we're really talking about is if you removed the water. So if you were to take these organisms and you have to kill them to do this, so we estimate this, we don't actually measure it. But you would kill it and then you would dry it out so that all of the water is removed. And the reason for that is when you remove all of the water, what you have left are called biomolecules. And biomolecules are the organisms, molecules of life. So there are a bunch of different types of biomolecules, and we're going to be learning about those later. But in reality, biomass is really the mass of the biomolecules. So that's going to be things like protein and carbohydrates, DNA. Those are all types of biomolecules. All right, moving on. I'm going to turn this one more time. We're now working in this triangle here. And in this triangle, I'm going to make a pyramid of biomass. So in a pyramid of biomass, again, it's going to be kind of a pyramid shape, but we're going to start at the bottom. And so in my pyramid of biomass, I'm going to have, oops, my orange pen doesn't want to write that well. I'm going to have at the very bottom my producers. And in this case, it's my grass. And if I were to find the biomass of all of the grass in all of the Serengeti, if you calculate that all out, you actually get 3.3 times 10 to the 11th. That's a lot. It's like way more than a billion. Kilojoules is the unit. And a kilojoule is a unit of energy, and it works out to be about 4 calories in 1 kilojoule. Okay, if we then build up, the next level are going to be all of our wildebeest. And if I want to put my wildebeest here, it's going to be a smaller amount of biomass than in my grasses. And my wildebeest make up 3.3 times 10 to the 10th kilojoules of energy. And the reason for this is we have this thing called the 10% rule. And the 10% rule says that only 10% of the energy can go from one level to the next. So that is how much energy can be transferred up this food chain. All right, and the final level here are going to be my lions. And it's so much smaller that I can't actually write it in this box. So it's going to have to get an arrow. Now, my lions are in here, and my lions are going to only receive 10% of the energy, which means that they are going to have 3.3 times 10 to the 9. And that's also in kilojoules. And what that works out to in terms of like calories or something that you can kind of picture in your head is all of the lions in the Serengeti, all of the energy that is stored in their biomolecules. If humans were to eat just lions, humans would be able to eat those lions for about a year, and about 1,000 humans could live off of those lions. That's how much energy there is. So humans need about 2,000 calories a day, and so that's how many lions they would have to eat. They would have to eat all of the lions in the Serengeti in 1 year to support about 1,000 humans. That's how much energy there is there. So that 10% rule says that only 10% of the energy is able to make it into the next level. Okay, last but not least, we are going to look at how are energy and biomass related. So I'm turning this again. We're going to kind of write down this definition here. So biomass, remember that that is the mass of the biomolecules. So biomass is equal to biomolecules. and that is equal to the chemical energy because there is chemical energy in the bonds between carbon and hydrogen atoms. So all of these biomolecules have carbon atoms and they have hydrogen atoms, and the bonds between those have chemical energy. So if you have more biomolecules, you have more chemical energy because you have more bonds, and if you have more bonds, you have more energy, you have more biomolecules, you have more biomass. So if you increase the biomass, you then increase the amount of energy. All right, those are our notes for today.